Most mechanical engineers in India are not struggling because mechanical is dead. They are struggling because they are solving closed form textbook problems in a world that rewards data driven system optimization. And here is the uncomfortable part: the highest paying mechanical roles today still belong to mechanical engineers, but they operate at the intersection of physics, data, and algorithms. If you are a mechanical student or graduate stuck between core jobs and coding confusion, this matters because the market has already shifted from design only roles to system level intelligence roles, and most people have not yet noticed. I am Manish Kumar. I have 12 plus years of experience in AI, data systems, and enterprise architecture, and I help engineers from tier 2 and tier 3 colleges to build AI proof careers with real world proof. So let's break the reality. Mechanical engineering education in India is still focusing on deterministic problem solving. You solve equations, you derive formulas, and you assume the ideal conditions. But real systems are not deterministic. They are stochastic, noisy, and time dependent. Machines degrade, sensors drift, data is incomplete. And here is the gap: you are trained on first principle analysis, but companies are hiring for system behavior under uncertainty. So, what happens? You graduate and you apply for roles like maintenance, production, quality control, and these roles are increasingly becoming standard operating procedure driven, low decision making, and low leverage and low growth. Then panic kicks in, and you jump into generic coding without domain linkage. That makes you neither a strong mechanical engineer nor a strong software engineer. And that is the trap. Here is the part most people miss: mechanical is not dying. Low signal, low data mechanical roles are being automated. So before I get into the fix, if this is making sense so far, hit that like and subscribe button. I put out content like this every week specifically for engineers figuring out the AI transition in India. It takes about 2 seconds and it genuinely helps the channel. Now let's talk about what actually works. The shift is simple. Mechanical engineering is moving from equation solving to system intelligence. And you need to operate across three layers. Layer number one, physics layer, and this is your foundation: thermodynamics, heat transfer, fluid flow, material science. But this is not for exams, this is for real world modeling. Examples are understanding failure modes, fatigue, creep, and thermal stress, because your AI model is only as good as your physical assumptions. Layer number two, data layer. Every modern mechanical system is instrumented. You are dealing with sensor data, telemetry data, vibration signals, temperature gradients, and pressure variations. These are time series data, not Excel sheets. You need to understand signal processing and basic noise filtering and feature extraction. Then use Python, NumPy, pandas, and basic ML models like regression classification and anomaly detection. Layer number three, the decision layer. This is where the compensation jumps because now you are influencing outcomes, not just observing the systems. Examples include predictive maintenance using remaining useful life, process optimization using constraint based models, energy efficiency using load forecasting and control systems, digital twins combination using simulation and real time feedback loops. Now, here is the part which surprises most of the people. You don't need deep learning to start. You need problem framing because most real world problems gain from better features, better assumptions, and better integration, not fancy models. Everything I just covered, I go deeply in my LinkedIn newsletter. It's called AI Empowered Hub. Every week, I write a detailed article for tier 2 and tier 3 engineers on how to position yourself in an AI first market. Link is in the description. You can subscribe if you want the full picture. Now, let me show you the proof. Let's make this real. I have seen mechanical engineers transition into digital twin engineers, reliability engineers with ML Smart, manufacturing analysis, and what they are doing differently. They are building the applied systems, not just the theoretical knowledge. Take a rotating machine, motor or pump, use its vibration data, apply FFT, and identify the frequency anomalies. Then build a simple anomaly detection model which will give you real predictive maintenance. Example 2 is production line bottleneck analysis. Use the throughput data, apply basic statistical model, and simulate the improvements. This is where the operation optimization happens. Example number 3 is energy system. Use load data, forecast consumption, optimize the usage, and that gives you energy intelligence. Did you notice something? None of this requires a PhD, but all of this requires integration. And this is what the companies reward because you are now reducing the cost and downtime and the risk, which causes the business impact. So now let's make this actionable. Step number 1, pick one system: motor, HVAC, pump, or production line. Go deep. Step number 2, add the instrumentation thinking, even if it is simulated, and create the time series data. Step number 3, build one decision use case: failure prediction, efficiency improvement, or anomaly detection, and do this for the next 30 days. If you do all this, you will stand out immediately because now you have proof. Mechanical engineering is not dead, it is being upgraded into an intelligence layer. If you stay at the equation level, you will get replaced. But if you moved to the system level, you get paid. So question the default. And if you're serious about this move and want more clarity on exactly which role fits you and what is your next 90 days plan looks like, I do a free one-on-one clarity call with no pitch and agenda, give you the 30 minutes of direction. Link is in the description. Spots are limited. See you in the next one.